Okay, all right. So here we go. Prompt 2 for today. Our focus is, well, yesterday we talked about multiplying monomials. Today is dividing. Okay? We came up with some rules yesterday, and today is the same way. I want you to actually discover some yourself. But here's the problem. The area of the triangle is 100 times a cubed times b. By reading that first sentence, what's given to you already? The area. Okay, you expect the area to be like one whole number, right? But that's not the case anymore. We know it could be anything. And so what's given is given. The area is given in the form of 100 times a cubed times b. And we also know that if it's a triangle, you should start thinking about, wait. Area of triangle, do we know the formula for the area of triangle before we begin? What is that? Okay, you said 1/2 times base times height. So we're going to start with that and say, okay, the area of a triangle is 1/2 times base times height. Now, according to this problem, let's continue on. It says to find the height of the triangles. That means the height is not given, is it? So we know that the area is given. What else is given in this problem then? The base. Okay, so we can say that the base is right here, and the height is here, which I don't know what it is, and the area is given. So giving the following information, what can you plug it into the formula? The height, the base, and the area. The area. So let's start plugging it in. The area is 100 a cubed b. It's 1/2 times the base, and we know the base is 20 a squared, right? And times it by the height. Notice how I grouped this together because I want to show you that the height is what we're trying to solve for. But we can certainly do some simplification if we can. Let's take a look at this. What is 1/2 times 20?
10.
Okay. Remember how we do number with number, right? We have to group them separately. Numbers with numbers, so we know it's going to be 10. So as I write that, you will see it's simply going to be 10a squared together, again, times h. We want to solve for h. If we want to solve for h, what do we need to get rid of? The 10a squared. How do we get rid of the 10a squared? What's linking them together? So how do we get rid of that? Dividing. Okay. So we divide 10a squared both sides. And so h now is whatever that is, and we need to know or learn how to simplify or clean up our mess here. It's a mess. And unlike yesterday, it's involved multiplications, right? Here, it's involved division. And we will learn some rules after this for us to simplify what I just circled. So we'll come back to this problem, and let's visit our theme for today, which is about dividing monomials. Okay, dividing monomials. So what is it all about? What's the fuzz, right? I mean, like, is it really that difficult? Well, it depends. It's as simple as dividing two numbers. For instance, imagine I give you 8 divided by 2, and a lot of you can probably tell me what the answer is, right? What's the answer? 4. So we expect the answer to be 4. Simple enough. Or we can also write this as 4/1. Do we agree? Yeah. Okay. Now, I want you to use the same strategy, too, as to solve this. Watch what happened. 8. Can we break down 8? What?
Yeah.
2 cubed. Or 2 times 2 times 2? 2 is right here, right? Isn't that 8 divided by 2?
Yeah.
Watch what happened. I realized that, hey, I can actually cancel something because the top and bottom looks exactly the same. If I cancel one, what's left over? 4. Oh, interesting. Is that the same answer? Yeah. And notice that if there's nothing left, that space is simply just a 1, isn't it? So therefore, you can just leave it as a 1.
Didn't we do that in 7?
I know. Yeah, and we're doing it again. But we're not just doing this. I want to use this technique, which is the easy technique, to show you, hopefully you can actually discover your own shortcut after this. So this is the pattern that you see. We break it, we cancel out like terms, and then what's left over is our answer. Okay, let's try one more. If I have, for example, 4/32. Okay, we can simplify, or we can do this. 2 times 2, right? And 32 is 2 times 2 times 2 times 2 times 2. Agree? Okay, so do we see like terms? We do. 1, 2. So what's left over? Nothing on top? It's just 1, right?
8.
So simply it's going to be 1/8. Question on that? Do you see a pattern yet?
Easy.
Okay, now, we'll take this a step further instead of giving you just numbers, I give you variables. So now let's say I have a to the 5th power divided by a to the 2nd power. I would just, employ the same technique. A to the 5th means how many a's am I going to have? A. Okay, 5 a's. Okay. All linked up by multiplications. And then I have a squared bottom, which means I have a times a. Okay, I can cross out like terms. How many like terms can I actually cross out? 2. So if I cross out 2 of them, what's left over? 8 cubed. And of course there's a 1 on the bottom, right? But we don't have to write it all the time. So if it's on the top, I just write it as a to the 3rd power. Any questions so far? I'm going to give you another example, and I'm going to ask you to come up with your quick rule here. Hopefully you can actually come up with one. We'll see. So now, what if I have a to the 4th power up here and a to the 7th here? Watch what happened. A to the 4th means a times a times a times a. Agree? Yes. A to the 7th means a times a times a times a times a times a times a. We can do that all the time if we want to, but then I wouldn't recommend it. Why?
Too long.
Yeah, it's too long. Imagine that I have a to the 30th power. Are you going to write a 30 times? But then you can argue saying, wait, but I can visualize that in my head. I have 30 a's on top and, whatever a's on the bottom. I can just kind of visualize that I can't. You can do that. But watch what happened, please. I know. 1, 2, 3, 4. If there's nothing on top, that's a 1. And so the final answer is 1 over a cubed, right? Okay. Look at the 2 answers that I have here. What's happening? What's dictating where your power is going to be in this case? Yes. Okay, notice how the a cubed here is on top. Look at it here. It's on the bottom. And my question is, when do you know it's going to be on top? When do you know it's going to be on the bottom? Yes?
When the exponent is bigger.
Thank you so much. Notice how the bigger the exponents, it's like the winner, the breadwinner of the family kind of deal. If it's the bigger ones will always win. Notice how the bigger one on top will claim that prize. The answer is going to be on top. Then what's happening here? Which one's bigger? The bottom. What happened to the answer? It's in the bottom. You see how it works so far? Please let me know if you feel like you know what's going on. But it's deeper than that. Remember I told you we don't want to keep on doing this. Do you see any other things that we can apply here to make it faster? What do you see?
Oh, you can subtract.
Subtraction. Yesterday we learned that multiplying, we can add them, right? Add the powers. This time when we divide, we subtract. But look, 5, take away 2, 3. 7, take away 4, 3. Interesting. Will that help us speed up the whole process? And we now know where to put our answers. Whatever is the bigger one, we'll get that answer. If it's on the bottom, it's on the bottom. If it's on the top, it's on the top. Any questions so far? Let me know. All right, fine. You don't have to ask. I'll ask. Check this one out. You tell me what the answer is. 32. 8. A to the 7. A to the 9. B to the 16. B to the 8.
Son of a rat.
C to the 8. C to the 5. Okay. So I gave you this problem right here, and you're like, Mr. Wood, are you kidding me? What? Think about this. Think of this problem as 4 problems in 1. Why did I say 4 in 1? Because you have what? The numbers, A, B, and C. But before you even say anything, you should be able to see where the answer is going to be. The first thing you should do is, wait, I can just draw that line to indicate the top and the bottom. Look at the number first. The 4, right? You say it's 4. 32 divided by 8 is 4. Where's the 4 going to be? On the top. So now you learned something. Good. What about the A? Where do you think the answer is going to be? Bottom. By what? By how many? 2. So how do you write that?
2.
A squared. What about the B?
B on top.
How many?
A.
C.
C on top. 3.
Perfect. You're done.
Yeah.
Oh my gosh.
Why?
What do you think of that? Yes. Huh? Question? What's that near the 2? The 2. This right here?
The 3.
Oh, this right here?
Yeah.
That's a 3. I'm
What
sorry.
does that look like?
It's my fantasy 3. It's 32. Sorry.
That's it.
It's the cool 3.
Looks like
Alright, but look at that. What do you think of that one? Is it complex? Really? Okay, any questions so far?
No.
Oh wow, okay. So we get to this point, and it's easy enough to determine where the answer is going to be, right? Okay, so let's make it a bit more, and so you can actually understand. We just learned the rules as well. We just subtract the powers. The greatest one subtract the smallest one, and of course it's in the bottom. The answer is going to be bottom, it's on top. So far that's all we learned. And then what if I give you a problem like this? Oh wait, no. Maybe this. Guys, what's 5 squared divided by 5 squared going to get you?
0, 1, 1.
Why? Why?
because it's negative.
Negative?
Same thing.
Oh, what's that?
It's a 5.
Oh.
Oh, it's the same thing. So what kind of generalization can you make out of that?
Zero.
Is that a negative 2?
No, it's not a negative 2. It's
It's 1.
square.
It's 1. It's 1.
Okay.
7.
What kind of assumption can you make out of all 3 cases?
They're all 1.
They're all what?
1.
1. Why?
Because they cancel each other out.
They cancel each other out. Yeah, they cancel each other out, right? You can expand it, and you see 5 squared means 5 times 5, 5 times 5 at the bottom. Cancel everything else. Everything. The only thing that's left over is 1. Okay, and we understand that. But then I want you to understand something else as well. We just also learned this rule that you established yourself, saying that the shortcut of not expanding is by subtractions, right? What is 2 minus 2?
Zero.
So is it clear to say this is 5 to the 0 power?
Yeah.
No.
No.
Is that true? Based on what we just established as a rule, that when we divide, it's the same thing as subtraction.
Yeah.
Okay? 7 to the 9 is also to 0 when you subtract. Over here, it's simply going to be 3 to the 0 power, right? So that means, what we're trying to say here is that this is equivalent to that. So that means anything to the 0 power should have an answer of 1. This is something else you need to learn. Anything to the 0 power is numero uno. Number 1. Okay? So if I ever give you like a trick question with like a whole bunch of terms inside, but then I enclose everything inside parentheses and raise it to the 0 power, you should be laughing. You're like, the answer is? The answer is? 1. Okay, now do you understand why it's 1? That's the reason why. Okay? Now that we just learned about positive powers, we just learned about the 0 power, guess what we learn next?
Negative.
Negative powers. Yay, new friends. Okay, so for this one, I want to show you something that's pretty interesting. I know you're learning it. All right, watch this. Here I have a line. It's not straight, but I told you human's not perfect, right? It's okay. Here's a 0.
Lines on human.
Here's a 1. Here's a 2. Here's a 3. Here's a negative 1. Here's a negative 2. Here's a negative 3. Here's a negative 4. Here's a 4. Okay, this is the number line, right? Any questions so far? Did I do it correctly?
Yes.
Good. I want you to look at these numbers right here on the number lines as exponents or powers. The power. Big O as known as the power of some base. So I'm going to give you the base right now. Here's my first base. First of all, my first base is going to be a 10. 10 to the first power is 10. So we know the answer is a 10. Agree? 10 to the second power is
5.
10 to the second power is
1,000.
10 to the second power.
100.
No.
I know, I'm just kidding. It's 100.
Oh, okay. 100.
How do you say 5?
How do you
Okay.
say 5?
Shh. Well, we know why,
I
right?
say 5 like this.
Excuse me.
5.
Hey, hey. Thanks. 10 squared, as we know, is 10 times 10. And so 10 times 10 is 100. It's easy. But I want you to start looking at the pattern too. 10 to the third.
Oh.
Do you see a pattern yet?
Oh, yes, I know.
You just added 0.
10 to the 4?
I was like,
Yeah, Isaiah.
just add a 0.
Okay. Well, it makes sense because you keep on multiplying 10, so you kind of add another 0. Or another way to see it is you moving the decimal one place to the right each time as you increase the power. So if you increase the power by 1, you multiply, you move the decimal by 1. But this applies to the base of 10. Okay. And then we see that. Watch what happened. If I go backwards now, I have 10,000, 1,000, 100, 10. We just learned about the 0 power. What is 10 to the 0 going to give you? 1. You see what's happening as I go this way?
Yeah.
I was gonna be 0.1.
Interesting. What did you say?
0.1.
0.1. So 10, you agree now. If I say 10 to the negative 1 power, we know what the answer is. It's going to be 0.1.
0.01.
And 10 to the negative 2nd power?
0.01.
0.01. 10 to the negative 3rd power?
0.001.
0.001. And 10 to the negative 4th power?
0.0001.
Ah.
Stop.
Huh. Okay. But it goes deeper in this. Watch what happens. Yeah. See, that's why I love the negative side. There's so much to see.
What the?
That's true.
Yeah, I know.
Oh, we're gonna go
Exactly.
and stop changing
Because
the paper?
this, it's like, no, never mind. Okay.
Crazy.
All right, watch. We also know that 0.1 can be written as a fraction, which is what?
1/10.
1/10. Watch. 1/10. What about 0.01?
1 over 100.
1 over 100. This?
1 over 1,000.
1 over 1,000. This?
1 over 10,000.
Ah. Wait a minute. Wait. I want you to see something here. You see this is negative 1 and 1, they're opposite each other? Watch what happened to the answer. This is 10. This is 1/10. Well, something's wrong. 100, 1 over 100. 1,000, 1 over 1,000. 10,000, 1 over 10,000. What did you just see? Reciprocal! Yes, thank you. Reciprocal. So we just actually found something. For negative powers, it doesn't mean you get back a negative answers. When you raise something to a negative power, you don't get back a negative answer, guys. You just get the reciprocal of the positive power. So just think of it this way. If 10 to the 2nd is 100, 10 to the negative 2nd is the reciprocal of that power. So it's 1 over 100. In other words, if you see a negative powers and you want to change it to a positive, or in this case, or to rewrite it, that's what you do. You just take the reciprocal of the positive power. Okay, so this is the pattern I want you to see. Now let's clear this up and I'll show you a little bit here, and it makes perfect sense when I show you this next one right here. Here we go. We all know now that 2 to the 3rd is 8, right? We just also discovered that when we have a negative power, what would happen to this? We just compare. Reciprocal of that, right? Which is 1 over 8, or another word is 1 over 2/3, right? So clearly,
I mean 2 squared. I mean cubed.
2 cubed, but clearly you see that the negative power is being changed to a positive, but to change a negative to a positive, what will happen to its position? It will what? Flip. Switch position kind of deal. Okay? So here's another rule that you need to remember. If you see a negative power, and you want to make it positive because we don't like negative to begin with because it's just too complex, too deep. Make, great things to see, but we don't want that. We can just flip its position to make it positive. So imagine if I have something like this. What if this is a negative power down here? How do I make it positive? You just flip it. So in this case, this will go where? On the top. And there it is. That's how you make it positive.
So then that'd be just 2 cubed.
Yes, it's going to be, and it kind of makes sense too, because we know that 2 to the negative cube is 1/8, right? And so 1 and 1/8, when you divide by the reciprocal, a fraction you times by the reciprocal, which is this, ends up being 8. And so it's the same thing as like flipping. Okay, so please write this rule down. When you want to change a negative to a positive power, you just flip its position. If it's on top to begin with, you change it down below. If it's on the bottom, you switch it back to the top to make it positive. So please, just make this into a good habit of, I don't want to deal with negative powers, I only want positive. So positive is actually my friend, it's easier to deal with. I want positive balance in my account anyway, no negative. So do away with negative by applying this simple rule, flipping, okay? So, why do I need to teach you all negative powers? Because your next problem, you see something like this. Imagine I have something like that. obviously, you cannot use the expansion rule. There's no way that you can expand a to the negative 7 power. You know how to expand a to the 5th. A times a times a times a 5 times, right? But a to the negative 7, I don't know that. But I just have a way to make it positive. Flip it. So in this case, if I flip it, where's it going to go?
Bottom.
Bottom. So if it's going to bottom, what's on top now?
A to the 5th power.
Wait, no.
Wait. But it's a positive power. Why do we need to flip it if it's a positive? We don't do anything with positive, remember? We leave it the way it is. So the only thing we need to flip is the negative.
Yes.
So we circle the negative only. If we take that and flip it, what's left over on top?
Nothing.
1. Nothing on top. It's just 1. So what you have down here now is this, right? Didn't we just learn this rule yesterday? That when you multiply, what do you do? What do you do to the powers?
You
Add. So in this case, answer is? That's it.
He had that cool shoulder move, like.
Okay? Alright. You know something hard is going to be coming. But we cleared that part so far? If it's positive, leave it alone. Only negative, we need to flip. Is that clear?
Yeah.
But you need to use the combination of both of yesterday and today too. When we multiply powers with the same base, we add them, and when we divide, we subtract. Okay? So look at this one right here. I have 16 over 8, and I have a to the negative 2nd, a to the 3rd, b to the negative 4th, b to the negative 9, c to the 7, and c to the negative 6. Okay, so I give you this complex problem, and you're going to probably just hate me for it, but fine. Go ahead and hate me all you want. But take a look at this one right here. The first thing you should focus on is I want to change on a negative to a positive. Power, anyway. So which one should I circle?
The A to the negative.
That one, that one,
And C.
that one, that one. So you rewrite it so that everything will be positive. So what would you say? What would you write? I still have 16 and 8, right? Remember, this applies to the power, guys. If I have a negative 16, leave that alone. That's a number. We don't care about that. It's the power that we deal with. So what do you write? Where do you think the A negative 2nd is going to be? Bottom. What about b to the negative 4th? Bottom. C7?
No. Wait.
Stop. Well, because it's positive, you don't move it anywhere. And then we go down below. A to the 3rd? Bottom, because it's positive, we begin with. B to the negative 9? Top? C? Top. See? I just do a switch. Notice everything now is a positive.
Then you just.
Positive stays a positive. Negative will need to be changed to a positive by flipping or switching the position. Okay? Now we just have to do what we need to do. We try to simplify. So take a look. First of all, we notice that there's something we can eliminate, right?
B5.
B5 where?
Top.
Top. So I'm just going to go ahead and write it out. Wait, 16 over 8 is
Two.
what?
Two on
2, top or bottom?
Top.
Top. Actually, we should go in order. A, B, and C, right?
Okay.
So let's do with the A. You see any of the A on top?
No.
No, but we have the same A as on bottom, right? So what is A squared and A third? A fifth. Okay. B now is B fifth, top, bottom. Top. What about C?
13.
C 13. Done.
C13. Oh, C4. That's what I was thinking.
Oh, come on. What are you thinking?
I was thinking about bombs. C4. C13, C4.
Okay, thank you. You know. Yeah, this seems to be going online too. You know that.
Oh.
Okay. By the way, that's with Centino. Can you talk about that?
Talk about what?
Nothing. Okay.
Oh, C4. Oh my
Okay, any
God.
questions so far? Questions so far? It's C to the 4th power. Say that. Okay.
C to the 4th power.
Oh, it has to do with power too. Interesting.
Uh-oh. You're making me in more trouble.
Okay. Are we clear on that part?
Yeah.
We're good? Alright. Watch what happened as we move back to the previous problem. By now, you should have enough knowledge to answer this question yourself. So let's just carry this over. I have 100 a to the 3rd over times b over 10a squared. Now, let's simplify. Let's do a number first. What is 100 over 10? 10. A third over a squared. Top or bottom? Top. What about the b?
B.
Top. Okay, and there it is. That's all we're doing. Thank you. Very good. Okay, any questions so far?
10. Wow.
What do you think of that?
Easy.
So, yes, Mark.
Haven't we learned this?
Huh?
Haven't we already learned this?
in 6th and 7th grade.
Pretty much, but a lot of you have forgotten already. But then don't forget, we also have 6th graders, incoming 7th graders who were 6th grader last year, who did not learn this stuff. So it's kind of weird that you should be able to do very well, extremely well at time 1, having learned this in 7th grade, right? And that's not the case all the time. Okay, any questions?
Nope.
All right, so let's do one last problem just for fun, and see if we can actually handle this. So this is the problem. I have 2, a to the 3rd, b to the -2nd, c to the 6th, everything raised to the 3rd power, over 3, a to the -5th power, b to the -3rd power, and c to the -3rd power again, everything raised to the 2nd power. Ooh. My dear something, what are we going to do here? Thank you. Very good. You recognize that. Very good. See how we have layers? You should take care of that first before you do anything else. So let's take care of it. All right, let's take care of the top first. What do you have? 6? Someone said 6?
No.
2 to the 3rd power is 6?
8.
Remember I told you about this yesterday? If I want you to get 6, I would write 2 times 3, not 2 to the 3rd. 8. You're bad. Of course, it is your bad. Moving on. A?
9.
A9. Very good. Next?
B
B-6. Next? C18. So it looks pretty complex at first, but then you just realize it's just a simple distribution.
Why is that 8?
Huh?
Why is that 8?
Why? Which one's 8? Oh, why is it 8? Because it's 2, and you have 3 of those. 2 times 2 times 2. Okay. All right, bottom, please.
9.
9.
8 to the
-10. -6. Aha. You see that? I'm not done. But then I realized I need to do some cleanup work, huh?
Yes.
I see negative, so what should I do with negative? Flip. So I'm just going to go circle everything here to make sure that I remember to flip everything. So I have 4 things to flip, right? Yes. Santina.
Why is it B-6 on the bottom?
B-6 in the bottom because it's 2 times -3.
No, it's not. Oh yeah, it is. Okay.
It happens to be.
I know. I kept thinking it was a base or something.
Okay. All right. We just have 2 different kind of things on 2 different levels. Okay. All right. Let's start flipping. Watch what happened. I have 8. I maintain the 8-9 because it's positive. I maintain a C18 because it's positive. But then, what do I need to move to the top? How many things am I going to move to the top?
3.
3 of them. Okay. First one.
B6.
A10. B6.
C6.
C6. And the bottom.
C6.
9.
B6.
B6. See that?
Kind of like bingo.
Because these 3 will go up, but that one will go down, right? The -6 will go down to make it positive, and that's what we have. All right, let's clean up something.
You can take the B6.
Let's clean it up. What can we clean up on the top here?
A.
The A, so we have A9 and A10, which will make it what?
A19.
A19.
A1.
And what about the C?
C24.
C18 and C6?
C24.
C24. But then the B now, B6 over B6?
Yeah, cancel out.
Cancel out, we don't care about that. And the 8 over 9.
Yeah.
Look at that. Extremely complex at first, but hey, that's how we solve this kind of thing, or simplify. Any questions so far? You good? We're cool?
Yeah.
Alright, so, let me show you your DMQ.